Characteristic properties of acids and bases. So here are the learning outcomes for this video lesson. Describe the characteristic properties of acids in terms of their reactions with metals, bases, carbonates. State that bases are oxides or hydroxides of metals and that alkalis are soluble bases. Here are some key properties of acids. Acids have sour taste. You have tasted foods in your daily life, they all contain acid due to the season. There's some sour taste in them. Acids are corrosive in nature or they penetrate the skin. You can even write they are harmful. Acids turn blue litmus paper red. So these are the some sources of acids in our daily life. This is vinegar. We have fruit vinegar and we have synthetic vinegar. Synthetic vinegar contains 6% of acid, while fruit vinegar contains 5% of the acid. Lemon contains acid, citric acid, as well as vitamin C. The other name for vitamin C is ascorbic acid. Tomato also contains acid. It's oxalic acid. Grapes contain tartaric acid. When the milk turns sour, the milk sugar converts into lactic acid. Milk sugar is lactose and it converts into acid, lactic acid, and contains acid and it is formic acid. The name formic comes from Latin word formica, which means ants. Now let's talk about alkalis. Alkalis are bases. Alkalis have bitter taste. All alkalis or metal hydroxides are bases, but all bases are not alkali. I will come to this in the later slide. Alkalis have soapy touch. They turns red litmus paper blue. So here are some examples of acids and bases around us. You see the scale starting from 0 and ending on 14. This is known as pH scale. From 0 to 7 or between 0 to 7, we have acid category. These all are acids or they contain acids. These have acid in them. And from 7 till 14, we have bases. You see the blood, baking soda, bleach, drain cleaner, laundry detergent, soap, they all are basic in nature. On the other hand, the acid produced in our stomach, which is hydrochloric acid, apple juice, coffee, milk, tomato, soft drinks, battery acid, even the rain falls is slightly acidic. So here's the actions of acids and alkalis on litmus paper. Remember, acids turn blue litmus paper red. You see the paper is blue, so it's turning red because the solution in which we are inserting this litmus paper is of acid. On the other hand, bases turn red litmus paper into blue. You see, if you insert this red litmus paper into a solution containing base, it will turn to blue. Now let's talk about some characteristic properties of acids in terms of their reactions with metals, bases, and carbonates. Whenever you react acid with metal, you will always get two products, metal salt plus hydrogen gas. You see, I have used red color for acid because it's the common reactant in all these reactions. And on the right hand side, that is the product side, this is the product side, I have used a green color for metal salt. Metal salt is one of the common products produced all the time whenever you react acid with metal, metal oxide, metal hydroxide, or metal carbonate. So the next reaction is between acid and metal oxide or metal hydroxide. In this case, again you will get metal salt, but this time along with water, not hydrogen gas. The last reaction is between acid and metal carbonate. This time, again, you are getting metal salt, but the other two products are water and carbon dioxide. Let me write the name of some acids for your convenience. Hydrochloric acid, this acid is produced in our stomach. Sulfuric acid, this acid is used in battery. Acidic or ethanoic acid, this acid is present in vinegar. When milk turns sour, it produces or it converts into lactic acid. Fruits contain acid like citric acid, ascorbic acid. Remember, I just said that ascorbic acid is also vitamin C. And there are many other examples of acids. Now you can predict the name of the salt if you know the acid. For example, if the acid is hydrochloric acid, the metal salt will be metal chloride. If the acid is sulfuric acid, the salt will be metal sulfate. In case of nitric acid, you will get metal nitrate. Now let's apply this concept to different reactions. For example, the first reaction is between hydrochloric acid and magnesium. Magnesium is a metal, hydrochloric acid is an acid. The product will be magnesium chloride, and the other product is hydrogen gas. So in this reaction, you will see some bubbles produced in the reaction mixture. The next reaction is between sulfuric acid plus iron. One of the product is iron sulfate. Can you predict the name of the other product? It is hydrogen gas.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Now, when hydrochloric acid is reacted with calcium oxide, the products will be calcium chloride and water. Can you predict the name of the products when acid is nitric acid and other reactant is potassium hydroxide? Remember, I've told you when acids are reacted with metal oxide or metal hydroxide, you will get salt and water. So you can easily write water as one of the product. What about the salt produced? The name of the metal is written here, so you'll write potassium. Acid is nitric acid. So in case of nitric acid, you will get nitrate. So potassium nitrate is the salt produced here. Can you predict the name of the products for the reaction between sulfuric acid and sodium carbonate? You see the acid is sulfuric acid and carbonate is sodium carbonate. This is the metal sodium, so you write sodium here. In case of sulfuric acid, the salt will be sulfate. So you will get sodium sulfate. And whenever you react metal carbonate with acid, you will get three products. Metal salt, I have just written the name of the salt, water, and carbon dioxide. So I will write water plus carbon dioxide. Now let's talk about bases. Bases are substances that cancel out or neutralizes the effect of acids. Bases are oxides or hydroxides of metals such as magnesium oxide, sodium hydroxide, etc. There are so many examples of there are so many examples of bases. You can include metals like magnesium, calcium, zinc, copper, etc. You can include metal oxides like copper oxide, calcium oxide. You can include metal hydroxides like sodium hydroxide, potassium hydroxide. I'm writing the name of some metals here: magnesium, calcium, copper. Metal oxide, I'm writing zinc oxide, calcium oxide, etc. For metal hydroxides, we have sodium hydroxide, potassium hydroxide. You can also have metal carbonates, which neutralizes the effects of acids. Metal carbonates. Common example is sodium carbonate. Metal hydroxides are alkalis. They are also known as soluble bases. This is Venn diagram for bases. In bases, you have all these substances which cancels out or neutralizes the effect of acids. But there are specific kind of bases which are metal hydroxides. We call them alkali. All alkali are bases, but all bases are not alkali. So I have to write alkali under another circle. So in this area, you have metals, metal oxides, metal carbonates. As they are not alkalis, but they are bases because they all cancel out the effect of acids. I've talked about a name of some acids. Now I am writing the formula for some acids here. For example, hydrochloric acid. The formula will be HCl. Sulfuric acid, H2SO4. Nitric acid, HNO3. phosphoric acid, H3PO4, and there are other acids also. Now, recall, whenever acid is hydrochloric acid, the name of the salt will be chloride. So, the salt must have Cl negative ion in the formula. In case of sulfuric acid, the salt will be sulfate, which means the salt must contain SO4 minus 2 ion. Similarly, for nitric acid, you will get the nitrate salt, and the salt must contain nitrate ion in the formula. Now I am writing the symbol equation this time for the reaction between hydrochloric acid and magnesium. Hydrochloric acid, the formula for hydrochloric acid is HCl. If you look at the periodic table, you will find the symbol for magnesium, which is Mg. The product will be magnesium chloride plus hydrogen gas. Hydrogen gas will be written as H2. In order to predict the formula of salt produced between magnesium and chlorine, you have to consider the valency or the group number for these elements. Magnesium is present in group 2, so it must contain +2 charge. Chlorine is present in group 7, so it must contain -1. Ignore their charges. Now these numbers will become subscripts, and these subscripts will be exchanged like this. And you will get MgCl2. For your convenience, I am writing the state symbols. Hydrochloric acid must be in water, AQ. Magnesium, solid, S. Magnesium chloride, it's an ionic compound, so it must be soluble in water, aqueous. H2 is gas, so you write G for H2. Now, this is the reaction between sulfuric acid and iron. The product is written iron 2 sulfate and hydrogen gas. Again, you can predict the formula between sulfate ion, and this time you have iron 2 plus ion. So you'll have Fe plus 2, SO4 minus 2. So you write -2 plus 2. Both the numbers are same, ignoring their charges. So these will be cancelled out to get 1. The subscript will be exchanged, and the formula will be FeSO4. So the final product will be FeSO4 plus H2. Reactant will be H2SO4 plus Fe. This is the reaction between hydrochloric acid and calcium oxide. The product is calcium chloride and water. So write the formula for hydrochloric acid, which is HCl. Calcium oxide, it must be CaO, because calcium belongs to group 2 and oxygen belongs to group 6. Now predicting the formula, that is the compound formed between calcium and chlorine. Calcium belongs to group 2, so it must carry +2 charge, chlorine -1, ignoring their charges. Now these subscripts will be exchanged. These numbers, which are subscripts, will be exchanged. You will get CaCl2. So the product will be CaCl2. The other product is water. Note one thing, I am not balancing these equations. This is the reaction between nitric acid and potassium hydroxide. The product is potassium nitrate and water. This time you have to predict the formula between potassium ion, which is K, and nitrate ion, NO3. Potassium belongs to group 1, so it must carry +1 charge. Nitrate carries -1 charge, ignoring their charges. These subscripts numbers will be exchanged. and you will get KNO3 as one of the product. So I'm writing the full equation here. Nitric acid HNO3 plus potassium hydroxide is KOH. KNO3 is one of the product and water is the other product. Now this is the reaction between sulfuric acid and sodium carbonate. The products are sodium sulfate plus water plus carbon dioxide. I'm writing the formula for sulfuric acid, which is H2SO4. Sodium carbonate is Na2CO3. The product is sodium sulfate. So let's predict the formula between sodium and sulfate ion. Sodium belongs to group 1, so it must carry +1 charge. Sulfate carries -2. Ignoring their charges, these subscripts 1 and 2 will be exchanged. So you will get Na2SO4. So Na2SO4, which is sodium sulfate. The other products will be water, H2O, and carbon dioxide, CO2. Bases. Bases are substances that cancel out or neutralizes acids. Cancel out or neutralizing have same meaning. It means they are cancelling out the effects of acid. Bases are oxides or hydroxides of metals such as magnesium oxide, sodium hydroxide. Some examples of bases. Now, in the first statement, I just said that any substance that cancels out or neutralizes the effects of acids. So you can have any substance acting as base if it is able to cancel out the effect of acid. So you have metals, metal oxides, metal hydroxides, metal carbonates. Now I'm writing the formula for some of these. For example, you can take any metal like magnesium, calcium, iron, metal oxide like copper oxide, calcium oxide, zinc oxide, metal hydroxide like sodium hydroxide, NaOH, potassium hydroxide, KOH, calcium hydroxide, CaOH whole twice, metal carbonate like calcium carbonate, CaCO3, sodium carbonate, Na2CO3, and there are so many examples, so etc. Now recall one more thing, metal hydroxides are alkalis. They are also known as soluble bases. So consider this Venn diagram. This is of bases. So within this diagram, you have to make one more circle, which is of alkali. Alkalis are soluble bases. Metal hydroxides like NaOH, CaOH whole twice, etc. Then you have bases, other bases like metal, metal oxide, metal hydroxide, metal carbonate. I am writing one example each. For metals, you have magnesium, metal oxide, calcium oxide, metal hydroxide can have potassium hydroxide, KOH, metal carbonate, sodium carbonate, Na2CO3, etc. So all these are bases. But you see, alkalis are bases, but all bases are not alkalis. That aqueous solutions of acids contain H positive ions and aqueous solutions of alkalis contain OH negative ions. Define acids as proton donors and bases as proton acceptors. Describe the characteristic properties of bases in terms of their reactions with acids, ammonium salts. State that a neutralization reaction occurs between an acid and a base. Describe the neutralization reaction between an acid and an alkali to produce water. Is the reaction equation. And aqueous solutions of acids contain H positive ions. This is because acids produces H positive ions in water or aqueous solution. Aqueous, the term aqueous comes from Latin word aqua, which means water. So what is H positive ion? You all know that the proton number of hydrogen is 1 and its nucleon number is also 1, which means it contains 1 proton and 1 electron. It does not contain any neutron, 0 neutron. Whenever hydrogen loses electron, it forms H positive ion. So that's electron is removed. Now it's left with only 1 proton. That's why you can also call it proton or H positive ion. H positive ion or proton is hydrogen atom without electron. So whenever an acid dissolves in water, it produces H positive ions in it. H positive ions are important for acids to show their acidity. When we talk about acidity, it means characteristic properties of acid. Characteristic properties of acids. You can include all the characteristic properties like taste, action on litmus paper, action or reaction on substances like metal, metal structures, compounds of metals like metal oxides, metal hydroxides, metal carbonates, and even on living organisms. This also includes their action on pH value, which is between 0 to 7. So these all depends on the production of H positive ions in the solution. In fact, acids dissociate to produce H positive ion in water. Remember, water is important for this. You can't have H positive ion in any other solvent. In the same way, an aqueous solutions of alkalis contain OH negative ions, just like acid. This is because alkalis produce OH negative ions in water or aqueous solution. You can take an example of alkali. You know that alkalis are soluble metal hydroxides. Soluble metal hydroxides like alkalis. NaOH is one example. If you dissolve in water, So it will produce an A positive ion aqueous plus OH negative ion. Let's take another example of alkali. This is a weak alkali, ammonia. Ammonia exists as a gas. When you dissolve this ammonia gas in water, again, being an alkali, it will produce OH negative ion. And from this water, H positive ion will be produced. So NH3 will take up that H positive ion to produce NH4 positive ion plus OH negative ion. Just like acids, OH negative ions are important for alkalis to show their alkalinity. So for any alkali to show their characteristic properties, they have to produce or they must contain OH negative ion. And for this reason, they need water. They can't produce this OH negative ion in any other solvent or liquid. Alkalis show their characteristic properties in water. This include their taste, like we know that they have bitter taste. Action on litmus paper. You know that alkalis turn litmus paper to blue. Their chemical action. Chemical action means reaction with acidic or acidic oxides, with acids and acidic oxides. They will definitely neutralizes the action of acids and acidic oxides due to the presence of this OH negative ion. Acids are proton donors and bases are proton acceptors. I've just explained you acid produces H positive ion in an aqueous solution. It's an acid, HCl. When you dissolve this in water, it will dissociate or split up to produce H positive ion plus Cl negative ion. This is important for being acid. And NH3. NH3 is a base or alkali which accepts that proton. NH3 aqueous plus H positive ion produces NH4 aqueous. Donate proton. And this one accepts proton. Now, these are the characteristic properties of bases in terms of their reactions with acids. For example, when acids are reacted with metal, metal oxide, metal hydroxide, metal carbonate, or metal bicarbonate, these all will be neutralized. So these all will be acting as a base here, which means they neutralizes the effect of acids. The effect of acid or acids. Now, when you react alkali with ammonium salt, you will get three products: salt, ammonia, plus water. Now, this is true for all the alkalis. They all will react with ammonium salt, releasing ammonia gas. You can take an example of alkali, and AOH is alkali. When you react ammonium salt like ammonium chloride and H4Cl, you will get salt plus ammonia. The formula of ammonia is NH3. Water, H2O is the formula for water. The salt will be between sodium and chloride ion. You can predict the formula. Sodium belongs to group 1. +1 is the charge. Chloride belongs to group 7. -1 is the charge. So the formula will be NaCl. The name of the salt is sodium chloride. The next one. When acids react with bases, neutralization reaction occurs. Salt is a common product. Salt is a neutral compound. Therefore, we call it as neutralization reaction. Acid plus base, salt. What else you will get? You will get water. Water is the other product produced here. For any neutralization reaction between any acid and alkali, you will write this equation. This is the ionic equation for the reaction between acid and alkali. This is produced by acid, H positive ion, and this is produced by alkali, OH negative ion, and they will join to produce water. Describe acids and alkalis in terms of their effects on litmus, thermophthalene, methyl orange. Define a strong acid as an acid that is completely dissociated in aqueous solution, and a weak acid as an acid that is partially dissociated in aqueous solution. State examples of strong acids, including hydrochloric acid, nitric acid, and sulfuric acid, and construct these symbol equations to show their complete dissociation. Here's an example. HCl gives H positive plus Cl negative ion. State examples of weak acids, including carboxylic acids, and construct the symbol equations to show their partial dissociations. For example, for ethanoic acid, CH3COOH is the formula for ethanoic acid. It will dissociate to give H positive ion and CH3COO ion. Describe how to compare hydrogen ion concentration, neutrality, relative acidity, and relative alkalinity in terms of color and pH using universal indicator paper. What are indicators? Indicators are dyes which change color when acids and bases are added. A universal indicator gives different colors in strong and weak acids and alkalis. In case of universal indicators, we'll compare the color with the color on indicator color charge. Compare the color with color on indicator paper charge. Color of different indicators in acidic and alkaline solutions. So first indicator is litmus paper. You can also have litmus solution. In case of acidic solution, it will turn to pink or red. For alkaline solution, it will turn to blue. Thermophthalene gives colorless solution for acids and blue for alkaline solutions. Methyl orange gives red color in acidic solution and yellow in alkaline solution. Bromothymol blue gives yellow in acidic solution, blue in alkaline solution. You have to learn this table. It will help you in solving questions in paper 4 as well as in paper 1 and paper 2. Learn these change in colors. Strong acids dissociate or ionizes completely in an aqueous solution. Now, what do you mean by dissociation or ionization? Dissociate or ionize means splitting up. So acids split up or break up in an aqueous solution completely. We are talking about strong acids. Now, these strong acids act as strong electrolytes. Their pH value ranges between 0 and 3. It includes all mineral acids. Some examples of strong acids are hydrochloric acid. You know the formula, which is HCl, nitric acid, which is HNO3, sulfuric acid, which is H2SO4, phosphoric acid, it is H3PO4. There are some other examples of strong acid like perchloric acid, which is HClO4. HClO4 is perchloric acid. Like strong acids, strong alkalis also dissociate ionizes completely in an aqueous solution. They also act as strong electrolytes. The pH value ranges between 11 and 14. Some examples of strong alkalis are sodium hydroxide, NaOH, potassium hydroxide, KOH, calcium hydroxide, CaOH whole twice, strontium hydroxide, SROH whole twice. Now, weak acids and alkalis, they are opposite to strong acids and strong alkalis. They dissociate or ionizes incompletely or partly or partially in an aqueous solution. They do not dissociate or split up completely. The reason is that the ions recombine to produce a molecule of acids and alkali. These acts as weak electrolytes. The pH values for weak acids ranges between 3 and 7, but the pH value for weak alkalis ranges between 7 and 11. So some examples of weak acids. Acetic acid, it's an organic acid. The formula will be CH2COOH. What are organic acids? Organic acids are organic compounds. Organic acid is an organic compound. And what are organic compounds? Organic compounds are those compounds which contain carbon as an essential elements. Contain carbon as an essential element. Now, this acid is very familiar to you, carbonic acid. You have these acids in soft drinks. When carbon dioxide reacts with water, it produces this acid. So formula will be H2CO3. Formic acid, formula is HCOOH. Formic acid, the word formic comes from Latin word formica, which means ants. Comes from Latin formica. The bite of ants contain this acid. Nitrous acid is HNO2. Some examples of weak alkalis. Ammonia. The formula for ammonia is NH3. Remember, ammonia acts as alkali in water because in water it will produce OH negative or hydroxyl ion, which is very important to show the alkalinity of alkalis. Methylamine. The formula will be CH3NH2. Simple equation to show the complete dissociation of strong acids in an aqueous solution. I'm giving you example for the complete dissociation of hydrochloric acid and sulfuric acid. For hydrochloric acid, you will start with HCl. You will either write HCl aqueous or HCl gas plus H2O liquid. On complete dissociation, it will give you H positive ion in aqueous solution plus Cl negative ion. Similarly, you can write the or construct the complete dissociation for H2SO4, which is sulfuric acid. H2SO4. Dissociation occurs between these two. You will not get H2, you will get H positive ion. You have two H here, so you'll write two H positive ion. and the other will be sulfate ion. You know the charge on sulfate ion, which is -2. So this will be the complete dissociation for sulfuric acid. Now let's do this for strong alkalis like NaOH, sodium hydroxide. NaOH aqueous, it will produces Na positive aqueous plus OH negative aqueous. In the same way, you can construct the ionic equation for other strong acids and strong alkalis. Now let's construct the equation to show the partial dissociation in weak acids and weak alkalis. For weak acid, I have taken ethanoic acid, CH3COOH. Now in this case, you have to show reversible sign because the ions produce rejoin or recombine to give the molecule of acid. And in case of acid, the dissociation will be from this side for organic acid. And you will get what? You will get CH3 COO minus aqueous plus H positive aqueous. For carbonic acid, the ionic equation will be like this for partial dissociation of carbonic acid. This is carbonic acid. Again, you have two hydrogen. So you write 2H positive ion, 2H positive aqueous plus CO3. You know the charge on CO3, carbonate ion, which is -2. Now I'm showing the incomplete dissociation for ammonium hydroxide or ammonia in water, weak alkali. Ammonia in water. So you write NH3 gas plus H2O liquid, NH4 positive plus OH negative aqueous. Use of universal indicator paper. Now it's a full range indicator. It's a full range indicator. Used to show relative acidity and relative alkalinity in terms of color and pH. Then in the end, we will compare the color. Compare the color with color on indicator color charts. Describe how you could measure the pH of acid and alkali solution. It's very easy. For this purpose, we use pH meter. pH meter is an instrument used to measure the pH of an acid. For acid, the pH will be between 0 to 7. For alkali, it should be between 7 to 14. 7 is neutral. Describe amphoteric oxides as oxides that react with acids and bases to produce salt and water. Classify oxides as acidic, including SO2 and CO2, basic, including CuO and CaO, or amphoteric, limited to Al2O3 and ZnO, related to metallic and non-metallic character. Basic oxides. All metal oxides are basic except Al, Pb, and Zn. Basic oxides neutralize acidic oxides or acids. Some examples of basic oxides like sodium oxide, which is Na2O, calcium oxide, which is CaO, copper 2 oxide, which is CuO. Acidic oxides. All non-metal oxides are acidic except CO, NO, and H2O. CO is carbon monoxide. NO is nitrogen monoxide. And you know H2O is water. Acidic oxides neutralize basic oxides or alkalis or base. So some examples of acidic oxides: CO2, which is carbon dioxide, SO2, sulfur dioxide, Cl2O, this is chlorine 1 oxide. Here's the periodic table. First of all, I'm going to draw the staircase line. Now this area is below staircase line, and this contains metals only. And you know that I've just explained that all metal oxides are basic except aluminium, lead, and zinc. Above staircase line, you have non-metals. And I've just explained all non-metals form acidic oxides except CO, NO, and H2O. So you have CO coming from C, NO coming from N. These two, including H2O, which is water, are not acidic oxides. They are neutral oxides. So now let's talk about neutral oxides. Neutral oxides are neither acidic nor basic. Neutral oxides like CO and NO are insoluble in water. So these two are also insoluble in water. Some examples: CO, carbon monoxide; NO, nitrogen monoxide; H2O, water. Basic oxides, on dissolving in water, produces alkali. For instance, if you dissolve Na2O in water, you will get alkali. Alkalis are soluble base or metal hydroxides. So you will get NaOH. In the same way, when you react calcium oxide with water, you will get what? Calcium hydroxide, which is CaOH whole twice. Recall the formula making between calcium and hydroxide. Calcium belongs to group 2. The valency will be +2. Hydroxide, it will be -1. Ignore their charges. What you will get? You will get this. CaOH whole twice. In case of copper 2 oxide, CuO, when you react with water, you will get copper 2 hydroxide. Acidic oxides, when acidic oxides are dissolved in water, produces acids. For example, when you are reacting CO2 with water, you will get carbonic acid, H2CO3. This is carbonic acid. In the same way, when you react SO2 with water, you will get H2SO3. SO3 is a sulfite ion. Here you will get sulfurous acid. Amphoteric oxides. Oxides of Al, Pb, and Zn are amphoteric. So formula will be for Al, Al2O3, aluminium oxide, Pb, lead 2 oxide, PbO, Zn, zinc oxide, ZnO. Amphoteric oxides react with both acid and base, which means they act as acidic as well as basic oxide. So here's the reaction between aluminium oxide and hydrochloric acid. We will get salt, AlCl3, which is aluminium chloride, and water. And when you react Al2O3 with alkali like sodium hydroxide, again you will get salt soluble in water, NaAlOH whole 4. So here you will find the amphoteric oxides in the periodic table. Aluminium, zinc, and lead. Amphoteric oxides.